Now let's go back to our example where we were selecting parts that we have manufactured and keeping track of the number of good parts and the number of defective parts. And let's look first at the case where we were selecting 2. So if we let x equal the number of good parts, and then we look at the number of ways to get x good parts, and then the probability that we would have that many good parts. Let's make a table out of that. That's going to be pretty much the same as that one that we have there. The only thing that we're adding to it is the number of ways to get x good parts. So we could have 0, 1, or 2. And the number of ways to get no good parts was only 1. And the number of ways to get 1 good part was 2. And the number of ways to get 2 good parts was 1. And the probabilities here were the probability of a defective squared 2 times the probability of a good times the probability of a defective, and the probability of a good squared. Now we could put an understood 1 right here and an understood 1 right here. And this 1 is going to match up with this 1 out front. This 2 is going to match up with this factor of 2 here. And this 1 is going to match up with this factor of 1 here. And we're doing some generalizing here that's going to help us to develop a bit of a formula a little bit later. Now let's go back to the case where we selected 3 parts and made a similar table. Now, let's do this. Let's make p, little p now. This is going to be a lowercase p. This is going to be the probability that we would get a good one. And what we're going to do is consider the selection of a good part a success. So this lowercase p, the probability that we would select a good part, we're then going to call the probability of a success. Then we're going to let a lowercase q be the probability of a failure, which in this case then is the only other possible thing that could happen, and that is that we would select a defective part. So then little p is going to be 0.9 and little q is going to be 0.1. Now let's look at some other notation. We're going to let n be the number of trials for this experiment. And that's just then going to be the number of times that we're going to select a part. So that turns out to be 3. Now, there are some criteria here that we notice about this particular example. We have n, a finite number, of independent trials. Each successive trial of this experiment does not result in a different probability of a success. In other words, the probability of a success is not changing. So the probability of a success is consistent from trial to trial. And then there is one other thing that we notice about this particular experiment, and that is that there are only 2 possible outcomes either a success or a failure. So these three things that we have listed here, these three items that are true about this particular experiment, are the criteria for what we call a binomial experiment.